Hi, welcome to this introductory tutorial to the ZestSC2 FPGA plus USB platform from Orange Tree Technologies. Supplied with software support, libraries, logic cores and design examples, the ZestSC2 connects to a host PC through a high-speed USB 2.0 bus. In terms of performance, the ZestSC2 is capable of saturating the 480 megabits a second USB 2.0 bus, and it delivers a sustained 38 megabytes a second data rate. The ZestSC2 that you can see here is the big brother to the ZestSC1 and features some key differences in terms of its memory, power supply, FPGA device and the I/O. Taking a closer look at the board, we can start to see some of the main components in more detail. There is a choice of Xilinx Spartan 3 FPGAs, either the 3S2000 featuring 2 million gates or the larger 3S4000 with 4 million gates, and the FPGA can be configured from USB or via a JTAG cable to these header pins here. As used on the ZestSC1, the USB microcontroller is the Easy USB FX2 device from Cypress, and there is also 32 megabytes of SD RAM and 8 megabytes of onboard SRAM. The SRAM is pipeline ZBT, zero bus turnaround for no wait states between the writes and reads. The ZestSC2 is also fitted with flash memory for FPGA configuration, and this can be programmed either from the JTAG header or from USB. And for programming from the USB, a host utility is supplied with the board. The ZestSC2 is used across an array of end markets such as semiconductor prototype and test, industrial control and factory automation, communications, defence and aerospace, with typical applications including fibre channel network monitoring systems, radar and missile control test systems, displays and sensor controllers. And the compelling value proposition of coupling USB with FPGA technology is to provide the designer with lots of flexible I/O, field upgradability of the hardware through FPGA reconfiguration, and the opportunity for local to the end system parallel processing data actually inside the FPGA. I/O rich, the ZestSC2 is fitted with 4 64-pin headers for ribbon cable or to connect to a daughter card, 2 headers with 49 pins and 2 with 51 pins that provides 200 header pins of I/O to the user. 13 LEDs are provided on the board, 8 connected to the I/O pins, 4 for power indication that you can see here, and 1 for the FPGA done signal. With up to 95% efficiency, the onboard 10 watt power supply unit enables the board to be either bus powered from a high power USB port or self powered here from a wall adapter. If the board is fitted inside a PC, it can be connected to the hard disk drive power connector here. And a secondary USB port is also provided that enables up to 5 watts to be supplied from a host PC. 3 interfaces are provided between the USB chip and the FPGA. All are accessible using the host library that's supplied with the board, streaming, data streaming at the maximum USB bandwidth, registers, control and status registers in FPGA application, and signalling, single bit interrupt and flags. The FPGA clocks are fixed at 48 MHz for the streaming interface between USB and FPGA, and for the microcontroller registers interface between USB and FPGA. To provide an out-of-the-box experience, the ZestSC2 is supplied with a host library and drivers for configuring the FPGA and communicating with the FPGA that run on Windows and Linux. And we also provide IP in the form of optimized SRAM, SD-RAM and USB interface cores. And to accelerate design productivity, Design examples are included that consist of a host program and a Xilinx XST, VHDL or Verilog project. Models and test benches to illustrate how the various interfaces can be simulated before implementation. How to configure the FPGA from a bit file generated by the Xilinx place and route tools. How to use the high-speed streaming interface on the board by measuring data transfer rates between the FPGA and the host in either direction. How to use the low-speed control interface on the board. How to use the SRAM and how to use the SDRAM. And the board itself is designed into a small form factor, 150mm by 122, making it ideal for OEM or desktop use. So if you need more information about the ZestSC2 or some of the technology behind FPGA USB system interconnects, please visit orangetreetech.com and look out for more video sessions and tutorials where we run real-time design examples.